Okay, you've made it to the end of the Systems of Equations week. I'm going to do a little review, and at the end of the video, I'm going to show you a fourth method on how to solve these problems that's going to be very beneficial to you. So please watch the whole video. This is a little bit of review from yesterday. We solved by graphing. And when you graph two lines, they're going to intersect at one point only, and that point is the answer to the problem. So right here, these 2 points intersect at 3, -1. Therefore, x is equal to 3 and y is equal to -1. That's the solution to that system of equations. It's that easy. How do I know x is 3 and y is -1? Because this is an ordered pair, and you always do the x coordinate first and the y coordinate second. You went in the x direction 3 and the y direction down 1 to get to that point. You could run into a situation like this where your lines do not intersect, and if that happens, then there won't be a solution, because the solution is where they intersect. It's the point that is on both lines. This point 3, -1 is on both lines. If I would have claimed that this was the solution to that problem, 4, 0, I'd be half right. You can use it in this line because that point is on this line, but it is not on this line. Therefore, it's not a solution to both problems. The point that you pick, the solution that you pick, has got to work for both equations, not just one of them. Here, it doesn't matter what point in the whole universe that you pick, it's not going to be on both lines. You might pick one over here, that's not on either. You might pick this one, that's on one of them. This is on one of them, but there's no point that you can pick that's on both of them because they don't cross. And when that happens, when you have parallel lines, there's no solution. All right, it's always where the lines cross, and if they don't cross, there's no solution. Next, I wanted to review a story problem with a little bit of a different twist. I was giving you guys hamburgers and fries and Pokemon and Yu-Gi-Oh card problems where both equations look like this. You had a dollar amount for each one and a total amount, and then you had to make two equations and add or subtract them together to eliminate a variable. Here, it's a teeny bit different. The two equations aren't going to look exactly the same. They're not going to be set up exactly the same, so let me walk you through this. This is a story about selling tickets to an event. And you could sell a ticket for general admission, or you can sell a ticket to senior citizens. They get a discount. Their tickets are only $3 each. The general admission pays $5 each. So this equation over here is telling you that you sold a certain amount of general admission for $5 each, a certain amount for $3 each, and you sold a total of $39 worth of tickets. That's not quite enough information to know exactly how many general you sold and how many seniors you sold. You need a second equation to try and figure this out because we have two unknowns. So that's where this comes into play. You sold 10 tickets total. 10 tickets total. And the question is here, how many of each ticket did you sell? How many of each ticket? So in this equation, you can say, well, you sold a certain amount of G plus a certain amount of S tickets, and that would for a total of 10 tickets. So that's your equation there. Whenever they give you the total amount of sold and a number, it's just your two variables add together equal that number, 10. If I would have said you sold 20 tickets, it'd be G plus S equals 20. The number of general plus the number of seniors equals 20 if this was 20. But it's 10, so it's equal 10. Over here, it's 5G, 5 general tickets, or I'm sorry, $5 per ticket plus $3 per senior ticket was equal to a total of $39. Those are your two equations. That's how you set up the two equations in a problem like this. And there is a problem like this on the do section today, where you have to set it up just like that. So it's now you have your two equations. Now you can start solving the problem. Here's equation 1. Or I'll start with equation 2 because those are bigger numbers. 5G plus 3S is equal to 39, and here we have G plus S is equal to 10. I'm going to use the elimination method by getting one of my variables to match up here. And I'm going to use the smaller one so I can keep my numbers smaller. I'm going to triple this order here. I'm going to say that this is 3G, 3S, and 30. I'm going to distribute a 3 through that whole equation. That way I match up my S's. So if I triple everything, that becomes 3G, 3S, and 30. I distributed a 3 through that equation. Now I can subtract and my S's will go away. And I will get 2G 2G is equal to 9. And then you divide by 2, and G is equal to 4.5. So you sold 4.5 tickets, which I know doesn't really make sense, but since you sold 4.5 general tickets, what do you add to 4.5 to get 10? 5.5. So it was 4.5 general, 5.5 senior. That was the answer to that one. I better show you one more though, since that one was new and it came out to decimals, which really isn't realistic when you're selling tickets. You're not selling half tickets. So let's say the general tickets cost $2 and the senior tickets cost $1, and you sold a total, we'll do 10 tickets again. 10 tickets, and the total amount of money you brought in was $15. All right, so your first equation, I'm going to use the cost again. That would be 2G plus 1S, which is just S, was equal to 15. And then here you have G plus S equals 10. G plus S equals 10. Now I don't have to change anything because the S's already match up, so I can just get straight to subtracting. And when you subtract, you get 1G is equal to 5. And then you substitute that into the next equation, and you get 5 plus S is equal to 10. You subtract 5 to the other side, and S was equal to 5. So you actually sold 5 of each in this problem. You sold 5 general and you sold 5 seniors. 5 generals at $2 each, that's a $10 total. 1 senior at $5 each, that's 5. 10 plus 5 is 15. So they're both 5 in that one. So that's how you set up those types of problems. All right, and then finally, the fourth method, which is going to be a lifesaver. I kind of broke you into this yesterday. With the do section, they wanted you to check the problem. So you were substituting in the numbers they gave you for X and Y into the equation to see if they worked. That's basically called guess and check. And that's what a multiple choice test gives to you. They give you the answer somewhere in your 4 choices. I'm only giving you 2 choices here because I don't want to go through a bunch of choices. But to guess and check, instead of trying to solve for this, which this is not going to be easy to solve for because your variables aren't lined up, so you can't just add or subtract them together to eliminate one. You don't have a variable all by itself, so substitution isn't going to be real easy. That doesn't look like fun to graph. Graphing's not going to be easy. So none of the methods that we've learned so far, elimination, substitution, or graphing, look very easy for this. So when you get one that looks tough, you could just guess and check. You could just start substituting 2 for X and 3 for Y into the equation and see if it works. If it doesn't, then you try B. So it's real similar to what you did on the do section yesterday. So you've already kind of practiced this a little bit. So let's try that. Put 2 in for X, and you'll get 4 times 2, and put 3 in for Y, and you'll get 7 times 3. Does that equal negative 13? Well, 4 times 2 is 8. 3 times 7 is 13. I'm sorry, 21. And 8 minus 21 is negative 13. So it works for the first equation, but you got to check both. Remember, the point that they give you has to be on both lines, not just one of them. So you got to check the second equation too and see if it works. So you put a 2 in for x. 2 times 2 is 4. 1 plus y was 3. 4 equals 4. So hey, there you go. The first one you tried worked, then you're done. That's the answer. If it doesn't work, then you have to check the next one. If that doesn't work, you have to check the next one. So that will actually work for every single problem on the test. You could do that on every single problem, but it's like doing 4 problems in one. If the answer is D, you keep checking and checking and checking and checking. So sometimes it can take a long time. It's usually better to do the other methods if the problem is set up real nice for one of those methods. Like if the problem was set up like this, negative 2x plus 3y equals 5, and 2x plus 4y equals 9. Then that problem is just set up to just add the 2 equations together, and you're going to eliminate your x's. You have the same amount of x's, one's positive and one's negative, so if you add them together, they cancel out. So you get 7y is equal to 14, y is equal to 2. And that was pretty simple. So you will have problems like that are set up real nice for you. You don't have to really change anything. You don't have to guess and check. You can just solve it real fast. So you can still guess and check on these if you want, but you can see how guess and check is going to be tedious. It might take a little while. Guess and check is good, though, if the problem is not set up nicely and it's going to be difficult to solve for, then guess and check might work for you.